Ever feel like you need a crash course on AI?
Right.
But who wants to, sift through tons of textbooks?
Right.
Well, you're in luck. This deep dive is brought to you by Dr. Abuhmida. We're using her own course materials to break down some seriously cool AI concepts.
Yeah, and let me tell you, it's clear Dr. Abuhmida knows her stuff. These materials are comprehensive.
Hey, everyone, and welcome back. We talk about AI all the time, these algorithms that seem to be everywhere these days.
But it all comes down to data, right?
Exactly. The data itself is like the raw material being fed into these complex systems. So today,
We're going deep, getting into those nuts and bolts.
we're doing a deep dive into data types, those building blocks that make AI possible. And not just that, we're going to tackle this really common problem, missing data. Because, let's be honest.
It's like building a house on a foundation with cracks, right?
What?
You need that solid base.
Exactly. And to help us understand this better, we're turning to Dr. Abuhmida's work, Computational Applications of Artificial Intelligence.
Great read. She really breaks down these concepts in a clear way.
She does. She uses this fascinating example, the Titanic dataset, to illustrate how different data types come into play.
The Titanic dataset, a classic. It's almost like a rite of passage in the data science world.
So let's start unpacking this. First up, numerical data. Think of it as the measurable stuff.
Ages of passengers, ticket fares, things you can actually quantify. Like in the Titanic dataset, you even have the number of lifeboats. All numerical data.
And even within numerical data, there are different flavors, right? You've got continuous versus discrete.
Right. Continuous data is like someone's age. It can be any value within a range. You could even have fractions. But discrete data, that has to be whole numbers, like how many siblings a passenger might have had on board. Can't have half a sibling.
That would be interesting data for the AI to unpack for sure.
Yeah.
Okay, so we've got our numbers straight. What about the other types of data?
Well, you've got categorical data, which is all about labels and categories. Think about things like passenger class on the Titanic, first class, second class, third class, predefined buckets.
And this is where things get interesting, right? Because those categories aren't always equal in a hierarchical sense.
Exactly. That's where the distinction between ordinal and nominal data comes in. Ordinal data, the categories have a natural order, like those ticket classes, right? One is generally considered better than the other.
Even if it's subjective, there's a sense of ranking.
Exactly. But with nominal data, there's no such ranking, just different categories, like the nationalities of passengers. You can't really say one nationality is better than another. They're just different labels.
Okay, so we've got our numbers, we've got our categories. What else is there?
Well, you can't forget about date and time data. Tells us when things happened.
Crucial for understanding any historical event, especially on a timeline as significant as the Titanic. But I'm guessing it's not as straightforward as it looks.
You're right, there's always a catch. Think about the different time zones back then, or even just how dates were formatted. Those inconsistencies can mess things up if you're not careful.
And always just when you think you've got a handle on things, you come across mixed data. What's that all about?
So picture this. You've got a column in your data set labeled passenger information, but it's got a jumble of numbers, letters, maybe even special characters.
Sounds messy.
It can be. Imagine trying to decipher if those characters relate to a cabin number or maybe some dietary preferences. Who knows? It's like the data equivalent of a junk drawer. And that leads us right into the next challenge. Those pesky missing values. Because with mixed data, it can be even harder to tell what's truly missing and what's just hidden in plain sight.
It's like that classic mystery trope, right? The missing piece of the puzzle, the blank space on the map where X marks the spot. But instead of buried treasure.
We're talking about missing data. And trust me, in the world of AI, those gaps can be a real headache.
Because it's not like we're just missing a bit of trivia, right?
Mm.
These missing values can actually throw a wrench into the whole AI process.
Exactly. It's not just about the information that's absent. It's about the knock-on effects it can have. The accuracy of your models, the reliability of your insights, all of that can get skewed.
So going back to our Titanic example, what are some of the reasons we might encounter missing data in the first place? I mean, it's not like those passengers could just hit submit and forget to fill out a field.
Well, some of it boils down to good old-fashioned human error. Imagine a busy dock, people scrambling to get on board, a clerk trying to jot down details on the fly. It's easy to see how something could get missed.
And that's even before we factor in the whole digital revolution, right? No spreadsheets or databases back then.
Exactly. But sometimes the data might be missing because it never existed in the first place. Think about it. If we wanted to analyze the text messages sent between passengers on the
But
Titanic,
be out of luck. Testing hadn't exactly taken off yet.
precisely, that data is inherently missing, not because someone forgot to record it, but because it simply didn't exist in that time period. Then, of course, you've got those missing values that are a result of technical issues, maybe a data entry error, or perhaps a calculation that resulted in something impossible, like trying to divide by zero.
A recipe for disaster
Oh,
in
yeah.
any era. So, given that we can't hop in a time machine and force those Titanic passengers to fill out their information correctly, how do we deal with these gaps in the data?
That's where things get interesting. Data scientists have a whole toolbox of techniques for handling missing data. And like any good craftsperson, knowing which tool to use and when is crucial.
So there's no one-size-fits-all solution.
Unfortunately not. But let's start with the simplest approach. Complete case analysis, or CCA for short. Imagine you've got a stack of those passenger records, some complete, some with missing fields. With CCA, you're essentially saying, out with the incomplete, I only want to work with the pristine records.
Sounds almost too easy. What's the catch?
Well, for starters, you might end up throwing out a significant chunk of your data, especially if those missing values are common. And here's the bigger issue. If the data is missing in a systematic way, like if certain groups of people were less likely to have their information recorded accurately, then CCA can actually introduce bias into your analysis.
So in the case of the Titanic, if, say, passengers traveling in lower classes were less likely to have their ages recorded accurately, just tossing those records out could give us a skewed view of the overall passenger demographics.
Exactly. You're potentially reinforcing existing biases by eliminating the very data points that might reveal those biases. So while CCA can be useful in some cases, particularly when the missing data is truly random, it's often not the ideal approach.
Okay, so we need to be a bit more sophisticated in our approach. What other tools do we have in our data repair kit?
Well, a commonly used technique is mean-median imputation. Let's say we're looking at that Titanic data set, and we notice some missing ages. With this method, we'd essentially fill in those blanks by using either the average age of the passengers, that's the mean, or the middle value in the age range, the median.
So we're using the existing data to make an educated guess about the missing values. But how do we decide whether to use the mean or the median? Is one inherently better than the other?
Great question. It really depends on the data itself. If the data is normally distributed, meaning it follows that bell curve shape, then the mean can be a good choice. But if the data is skewed, meaning there are a few extreme values that pull the average up or down, then the median might be a better representation of the typical value.
So if the data is skewed, we use the median instead of the mean. Makes sense. But what happens when we're not dealing with numbers? What if we're trying to fill in those missing categorical values, like the passenger class example?
Well, in those cases, using the mean or median wouldn't make much sense, would it? You can't really have an average passenger class.
Right, you'd end up with something nonsensical.
Exactly. That's where techniques like mode imputation come in handy. Instead of calculating averages, we look for the most frequent value within a category.
So if we were missing data on passenger class, we might look at the most common class among passengers with similar ages, ticket fares, and other relevant information. Essentially, we're trying to find the best fit based on the available clues.
Right. It's about making the most informed guess we can based on the patterns we observe in the existing data. But sometimes, instead of trying to fill in the blanks, it's actually more helpful to just acknowledge them.
Acknowledge them. You mean leave the missing values as they are?
Not exactly. We can use a technique called arbitrary value imputation, where we replace those missing values with a placeholder. It could be something like NA for not available, or a specific numerical code like 999 to flag those missing data points.
So it's like putting up a sign that says, hey, we know something should be here, but it's missing.
Precisely. And this can be really helpful for a couple of reasons. First, it prevents us from accidentally treating those missing values as if they were actual data points.
Because an empty cell in a spreadsheet isn't the same as a cell that explicitly says not available.
Exactly. And second, using a placeholder can actually help us identify potential patterns in the missing data itself. If we see a lot of NAs cluster around a particular time period or within a specific group of passengers, that might give us some clues about why that data is missing in the first place.
So it's not just about filling in the gaps, it's about understanding what those gaps might be telling us.
Absolutely. Missing data, in a way, is like a hidden layer of information within our data sets. And by carefully considering how to handle it, we can unlock even richer insights and build more robust AI models.
It's amazing how much complexity is hidden within those seemingly empty cells. It's a great reminder that data is rarely perfect, but even imperfect data can be incredibly valuable if we know how to approach it. Well, that's all the time we have for today's deep dive. We hope this exploration into the world of data types and missing data has given you a new appreciation for the often invisible work that goes into building AI. Join us next time as we continue to explore the fascinating world of AI and its impact on our lives.